Hey guys, welcome back. Today we're going to be hooking up our generic wiring harness to the stock 1939 Ford headlight switch. Alright, so these generic harnesses like I get from Haywire or a generic harness from American Auto Wire, all that kind of stuff, usually way cheaper than a vehicle specific harness because they're not making millions of 1939 Ford harnesses, but they are making millions of generic 21 circuit wiring harness, right? So those are always cheaper. Also, when you get an original style wiring harness, especially for a car like this, it has nothing extra. No electric seats, no fancy radios, no electric windows, you name it, electric fan. It's got nothing extra. It's like bare bones stuff. So if you ever wanted to upgrade this car, 5 years from now or 6 months from now, you won't have any of the nice upgrades. So I always put a generic harness in every car, 21 circuit Haywire wiring harness in everything that I do. Also, I like to use a lot of original switches. There's no need to put some aftermarket ugly switch in the dash here. I mean, we have some options for customized switches. There's a lot of good options out there, but this customer wants more of a stock look. So we're gonna give them a stock look and use the original headlight switch. Now, a lot of people get overwhelmed with stuff like this because this looks nothing like, well, let me go get the GM switch that came with this kit and I'll show you a huge difference here. So these aftermarket kits will come with a modern GM style headlight switch. A lot of the kits will even come with the plug. The plug's just right in. You don't even have to wire the switch. You just gotta plug it in. But for some builds, some cars, you don't want this type of switch. You want the original switch. So this switch goes through the column, and on the horn ring, you spin it back and forth to turn your headlights on. You switch it the other way to turn your brights on. So there is no high-low beam switch in the floor, and it's actually a really clean look. So we're gonna make that operational here with what we have in the new harness with all of our new fancy relays and all that kind of stuff. So what I'm gonna do here is I'm gonna show you, really, I'm gonna diagnose this switch right here in front of you. I don't know which one's which. I don't have a wiring diagram. You don't really need all that kind of stuff. We can work on stuff with zero wiring diagrams whatsoever. All you need is an ohm meter, some test lights, and I like to use a Milwaukee little power pack to actually test things with power throughout the car because some things won't switch without actual power source. But here we don't need all that kind of stuff. We just need an ohm meter. We need to figure out where the power is going in, how the switch works, and where the power is coming out. So if we want high beam to be turning that horn ring to the left, it's going to be to the left. If we want low beam turning the horn ring to the left, vice versa. We have some options here to play with. So sometimes though, depends on the thickness of the wire, but we'll see what we have here. We're just going to work it and diagnose it in real time right here in front of you guys. So really simple. I have just an ohm meter. This is a super duper fancy snap-on one. You don't need that. You can go get a cheap one from the auto parts store. Mine has this nice tone. That's all I really like about it. When you get continuity between the leads, so that's nice. It's nice having a audible tone while you're working. Your hands are all full, and this is underneath the dash or something crazy. You have audible tone. Then I always have alligator clips when I play with power side stuff. I have alligator clips that actually have a fuse in it. This I'm just doing resistance, so these are just two of my generic alligator clips because I lost my alligator clips for this like 15 years ago. So otherwise I'd be putting alligator clips on the voltmeter. But let's test this. So let's just figure out how the switch works. Now I've already taken this apart and cleaned it. This thing was filthy. The way that they set these up on the early Fords where this is at the end of the steering column. Whenever the steering column drains or leaks, it leaks all over the switch. Whenever the motor leaks, it leaks all over the switch. So this thing was super, super nasty when I got it. You can kind of see it here on this, how gross it is. But the switch side, I got it all cleaned up and the contacts look good. So that's why I wanted to diagnose this to get it to be operational because the contacts work. So since the contacts are usable, we are going to rewire this switch into our new harness. So when I cut this apart, I was smart about how I cut it apart, okay? So in the harness, it went like this. So I kept the wires in the direction that they were going. This was going towards the radiator support, so it was going to the front of the car. So hey, what do you think? Those are probably left and right headlights. Just a guess, without even diagnosing anything, okay? This side all went to the car, so we gotta think about it. This also honks the horn. Let's turn the high beams on. It turns the low beams on. It turns your dash lights on. So there's a lot coming out of this. That's why there's so many wires. You look at it at first, it's like, oh my gosh, there's so many wires. No. This is simple. It's just supplying power once the switch is turned. That easy. Okay, so now I'm gonna take it apart so you can see what it looks like. So we have contacts here. The brass is the contacts, the plastic divots. It's just a slot for it to go neutral so nothing's on. So you can turn your headlights off, park the car and walk away and nothing's turned on in the car. Spin it, so you spin that horn ring. It just has two tabs on the end of the steering column that spins these prongs in here. This is an on and off switch. You see all these prongs? It turns everything on, turns everything off. It just tells you which connector to push the power through. Really simple. So I hope you could see that in there. And you can see the switch side here. So my voltmeter's turning off because it's taking me too long. So this side spins, okay? It spins like this. So hopefully you can see it. Just back and forth. It has 3 positions. So this looks crazy in here. This looks crazy in here, but it's only 3 positions. So it's gonna spin and contact multiple wires at one time. Try not to sneeze. It's gonna go back. It's gonna touch all the plastic pieces. So it's gonna be off everything. You spin it the opposite direction, it's gonna come in contact to send power through different wires. So this is really, really simple switch. This is very easy stuff, guys. Trust me, this is very easy. 3 positions. Neutral is off everything. Left is on certain wires, right is on certain wires. So now let's go ahead and diagnose this. Will you stop talking to me? Let me get this set back up. Turn my power volume on. Just tell me when there's continuity. Okay, so just from experience, I'm gonna jump the gun on one thing. I know which one's the power source. That's always pretty simple. I've looked it up like 15 times. Forgot which one it was, looked it up again. This time I actually kind of remember it. So the power source is like one of the biggest wires. We have 2 big wires here. One's gonna be the power source. One's gonna be high beams. High beams needs more amps. Hopefully you don't hear the bugs flying hitting my garage. One bigger wire is gonna be high beam. One bigger wire is gonna be power coming in. This is how it works on just about any circuit. High beams draw more amps. Okay, so now we're gonna supply power, which is my power lead to my ohm meter, to what I think is the power wire, which is the yellow with the red tracer. It's always the yellow with the red tracer. That's the main powers in the early Fords. But if you can't tell which one's which, it's gonna be one of the bigger wires is the power in, okay? So all I'm going to do is put an alligator clip on it so I have a free hand to run the switch. So the alligator clip is doing nothing other than just hanging onto the wire. We're gonna go over here to my power lead. So in and out, that's all we're doing. Always make sure your voltmeter's working, make sure your connections are good. So I just tested that my connection's good with my alligator leads. Nothing's more frustrating than trying to diagnose something when it's your tools that's making the mistake instead of you. So I got ohm meter side on my power coming in. I got my negative side to figure out where the power is going to go once I turn the switch. So I'm gonna put this switch in the hopefully neutral position here. I think that's neutral. It'll start buzzing at me if it's not, but that's okay. And this switch has a tab, or this housing has a tab on it, so it can only go on to the switch side one way. So the tab goes in there. Has a little spring to it, which is good. That's just the detents operating like how they should. And now I want to know, since these 2 wires, if you can look up in here, these 2 wires go to the same prong. So this isn't 2 different wires coming out. You have to think of these as they're the same wire because they both go to the exact same spot. So I don't care which one I hook this up to. Doesn't matter. I'm just going to hook them up together because they are the same wire. Okay? Don't let that get complicated. And I'm gonna hook this in here. So it's all connected, and I wanna know right now, where in the switch does this power go from the main end power wire to these two wires going out. So all I'm doing is putting pressure on this like the case would when it's closed, okay? Now I'm going to switch this with my flathead screwdriver into a different position. So it should be neutral in the middle, power on each end. So I switched it, so in the column, it'd just be a spin, the two tabs spinning, grabbing the two tabs on the inside, spinning that. So this is just a circular switch. In the middle is neutral, so I switched it to middle. So if I keep going counterclockwise, because that's what I did to get to the middle, it should power a different wire here in this system. And that other wire is going to be the high beams, because the low beams are going to be smaller wires. The high beams are always going to be a bigger wire on early Fords. The aftermarket harness, they're probably all going to be 14, 16 gauge. So now I switched it over to its last and final position. And there's only one more big wire here. That's got to be high beam. So I should hear continuity here. I do. So I'm going to hook this in and make sure this turns off in the opposite position, because we don't want this switch to be bad, put it in the car and wonder why things aren't working. So let's switch this to neutral. That's neutral, no power. Switch it one more time to headlights, and there should be no power too. Come on. Pop. There, pop. I was holding it too tight. So no continuity when the headlights are on. So I just figured out headlights, high beams. Now these other things here, one's going to be the horn, because the horn comes through here. I'll show you that in a second. Then another one is going to be dash lights. So high beams are on, there should be power to the dash lights. When the low beams are on, there should be power to the dash lights. When it's center, when there's no power to either headlights or brights, high beams, there should be no power here too. So let me see, where am I? Let's go ahead and turn the headlights on and make sure our dash lights turn on. So our headlights are on right now. Is our dash lights on? Yes? Yes. So both of these are on. Oh, okay. So one of these, see, I'm just diagnosing this in real time. So one, I didn't think about this until just now. One of these is also going to be the park lights in the back of the car. So both of these work for park lights. So park lights, dash lights, it doesn't really matter which one's which, because once I get these all labeled, I'm going to pull these wires off because they're just spades on the back, and I'm going to put brand new fresh wires on here. I ain't using any of these. I just want to know the positions and the connectors on the back of this. So we have park lights and we have dash lights. So let's go ahead and switch it to high beams and make sure we still have park lights and we still have headlights. So when we hook this up to our new harness, we want to make sure everything still works. It's just hard to do with a screwdriver. Sometimes I put too much tension on it. So I'm just confirming that my high beams are on. Yes. Now let's check our park lights. So we have park lights going to the tail light lights, and we have dash lights also. So we just diagnosed everything except for this one wire here. What is this wire? So now I can explain this one. This one's a unique wire, okay? This is a wire that might give you trouble, might not, depending on your connections, your setup, all that kind of thing. So this wire is easy to diagnose because I can visually see where it's going on the back here, okay? So we have a spring, and as this spring goes up and down, this goes up and down here. So we got to think about this. This is connected to a rod that goes all the way up to the top of the steering wheel. That rod is held up towards you, towards the driver, from a spring on the horn ring. So when you push that spring down, it pushes the whole rod down through the whole steering column and pushes this little button down right here. So right now this is telling me that the horn is getting stuck on. Also, this is a non-fused setup originally. This is not really a very safe type setup originally. Right now, the horn, I can guarantee you, is not working in the car the way that this was set up. So this, we're gonna put some grease in here. We're gonna spray it. We're gonna try to get this cleaned up and see if we can get the horn to start working again. But just like a normal horn ring, horn button on a normal, I wouldn't say brand new car because everything's a module now, but you know, a more modern old car. This pushes down enough, it gets contact and it just grounds the horn, okay? So the horn has supply power, the ground comes up here, it receives contact, grounds it to the steering column, and the horns honk. So right now, this is not going to work. I'm gonna see if I can take it apart and clean these contacts really good. So to overview, when you're trying to figure out switches, some of the things you can do is be very careful about how you cut it apart. Me knowing that these two go to the front, these other ones go to the back. Now this high beam might be going to the dash to tell your dash lights that the high beam's on. So a little indicator saying bing, high beams. Then it goes back to the bulbs. That might be why it just goes this way instead of straight forward. It needs to tell you somewhere in the car that your high beams are on, or if your high beams are off and your headlights are on. So that's probably why that's going that direction. Then we have two going forward. Two going forward coming off the same tong. So they're both just power. That's all they are. Both just power supplied. That's the headlights, okay? Then just how I diagnose in front of you guys. Oh yeah, dash lights and the tail lights. For some reason I forgot about the tail running lights. So now I can label these. I can take them out one at a time, put a new wire into it as I go. So this makes your life a lot easier, guys. Pull this out of the car, put it on a bench. Be careful about how you cut it out so you know an idea where everything's going. Cleaning up your contacts really good. This is all going to work just like brand new. I'll have to see about the horn, but as good as this looks, I think it's probably going to be okay. So I got the horn wire to work. I took this out, I sanded it down. I ended up drilling this plastic piece a little bit bigger so it slides better. All this does is retracting and pushing the horn rod up off of its contacts in the top of the steering column. So it works, it works, it works. So that works with me. What I did was I taped it up a lot further down, since that wire is actually going to get pushed down and pulled up at a different rate. None of these other ones are going to move at all. So at a completely different rate from everything around it. So it's isolated by itself, and it's going to be looking like that. So it should still look pretty clean up underneath the column. And all I'm going to do here is just build myself a connector right here. I like to use the GM flat connector. It's like 3 3/4 long, flat spade, but since this is going outside of the car, I'm going to use a WeatherPack waterproof connector that's going to allow this to get wet and not have any the connections corrode. So this is going to be a nice, good, reusable switch. All right, I wanted to show you what it looked like with my waterproof connectors on there. So boom, that's it. There's 6 wires coming out. Instead of having a big 6-prong connector, I did 2 3s, and they're the opposite ends. So you can't unplug this for some reason, plug it back in incorrectly. So it's impossible to plug in incorrectly. I mean, you can plug them into each other, it's not gonna do anything, but the harness into this, can't put it in the incorrect way. The other thing I was gonna say is all my wires here are printed, so it says what it is. Green is always high beam, but it says high beam on the wire. It says low beam on the wire. This is my power in, so that's gonna be ignition. I don't turn my headlights on without ignition. That's just the way I do things. You guys driving your car at night and you turn the key off, it's just gonna turn the headlights off, you go inside. Then we have a ground wire for the horn down here. This one says dash lights. It didn't print on there very good, but I am very aware of what it says. Then this is rear running lights. So this ended up looking really nice, I think, nice and organized. So thank you guys for watching all my videos. Let me know if you have any questions in the comments. See you next time.